So sitting in front of us, we have a random rock that I picked up from my yard and cleaned off a little bit. We have a rock climbing shoe. We have a sandal, and we have a force sensor with a push attachment on it. And what we're going to do is we're going to test the amount of static friction that exists between the rock and the soles of both the climbing shoe and the sandal shoe to see exactly how they compare to each other. So we'll start with the sandal shoe. So we're going to place the rock on the bottom of the shoe, just in no particular location, and we'll take our force sensor and we'll gradually apply more and more force to the rock until it starts sliding. And we'll use the force logger to figure out where that maximum is. So as we push harder and harder, we'll notice once it starts sliding, we'll ease off and we'll use that as a maximum static friction value. We'll do this 3 times to get a rough average of about how much force it takes to move the rock across the sole of the shoe. Now swapping out with the rock climbing shoe, if we put the same rock on that surface, we'll repeat the experiment and we'll see how these values compare. And so we can see graphically from the data logger that it is taking substantially more force to move the rock across the sole of the rock climbing shoe. So we'll do this 3 times and take a closer look at the data. So zooming into our data and looking at the minimum values, which are actually the maximum magnitude forces that we applied, because it's reading a negative number, we're getting around 5 or 5.5 newtons to move the rock across the sandal. And as the rock climbing shoe, we're looking at getting around 11 to 12-ish as an average there. So what we can conclude from this data, assuming that the normal force on the rock was the same for both shoes, is that the static friction coefficient between the sandal and the rock is much lower than the static friction between the rock climbing shoe and the rock.